And we're back. Last section, section 3, last part 3 of section 2.2. Let's get ready and get on, giddy up. Now it does say try the following with a partner, but hey, today it's just you and me, so let's go ahead and work this out together. All right. So I'm going to take a look at these limit problems. I'm going to do half-ish. I'm going to do probably 2 of them, and you're going to do the other 4 and see what we get. All right, so I'm going to go ahead and take on let's do number 2. I'm going to do number 2. So the goal with these, again, we have to ask ourselves what's happening here. So I still do all my same steps, okay, for finding a limit. So the first thing I'm going to do is I'm going to plug in 2. All right, so I go ahead and plug in 2. When I go ahead and I find that out, limit as x approaches 2 from the left, I'm going to say, well, it's 1 over, okay, 2 minus 2, which is equal to 1 over 0. Because I have a 1 over 0, again, what does that mean? That means that I have a vertical asymptote at that point. And so then it's my job as a calculus student to go in and try and figure out, okay, is that vertical asymptote, as I'm getting closer and closer from the left-hand side, is it going to go up or is it going to go down? That's my choice, and that's what I have to figure out, and I have to think out analytically. All right? So what I have to be thinking is, like, I have to do like a little sign chart in my head. Okay? And I have to be realizing, as I'm coming from the left, what does the left value of 2 mean? Well, if you need help, draw out a little number line. Here's 2. Where's to the left of 2? It's over here. That means it's like 1.99. So if I put 1.99 in there, all right, so now I'm going to have 1 over, and then now I have 1.99 minus 2. Is that a positive value or a negative value? I'm hoping that you see that as being a negative value. Because that's a negative value, I have 1 over a negative value, it's getting super small. Okay? So again, I already know there's a vertical asymptote because of this right here. This right here told me that it was going to be a vertical asymptote. Because it's 1 over a negative number, I know that my answer is going to be negative. So at that point, I'm able to say that the limit as x approaches 2 from the left of 1 over x minus 2 is equal to negative, that came from over here, infinity. And that infinity came from the vertical asymptote. Let's go ahead and talk about number 4, and then I'll leave the rest for you to do. All right. So for number 4, I'm going to go ahead and take a look here. Again, I'll do this one in red. And again, I do my same business. I'm going to go ahead and plug in 2. When I go ahead and just plug in 2, I get 2 over 0. Again, I know I have a vertical asymptote. All right. Again, I'm going to be going from the left. So now I need to go ahead and be thinking about, all right, what is going to be happening? So I need to do this whole sign chart. And I'm 2 from the left, so again, this can be stuff like 1.99. So if I'm taking a look at this and I have 1.99 over 1.99 minus 2, well, it's a lot like the top one, okay? A lot like number 2. I have a positive number up here divided by a negative number down here. And because I already know it's a vertical asymptote, so what's a positive or negative give me? Negative. So at this point, I'm able to say that it's a limit as x approaches 2 from the left, x over x minus 2 is going to be negative infinity. I'm going to go ahead and pause the video for you, and you're going to see whether or not your right answers. Do the other 4 and see where you get. And there are your answers. Hope you got all the right ones. We'll see what happens. If you don't get the right answers, please let me know, and we'll talk about it first thing tomorrow. All right, exercises here, these 54 and 55, I'm going to let you guys, we're going to do these in class. If you guys want to start on these and get an idea of what's happening, I'm actually going to have you guys work on these together in class tomorrow. I'm not going to talk about them here, but go ahead and try and get them figured out. Okay, especially this one down here, number 55. It's an excellent problem. All right, but we'll work on it together in class. Here we go. Now we're going to talk about something called end behavior models. Okay, if I have something that is y is equal to 2x squared plus a 4x plus a 2, and I'd have to say, as x gets bigger and bigger, what does the height of it look like? What does the picture of it look like? And that's what an end behavior model is. So what it is saying is, in general, okay, this polynomial will behave like, or at the end, in the end, it will look like 2x squared. Well, what does that mean exactly? What that means is if you put in both of these equations in your calculator, you're going to tell me, well, there's no way that 2x squared is equal to 2x squared plus 4x plus 2. If you guys have a calculator at home, put both of them in there, and you'll see, you're right, they don't look the same. But what happens when you zoom way out? When you zoom way out, they're going to start looking a lot the same. Okay? And that's what an end behavior model is that saying, you know what, if I zoom way out and I squint my eyes, do they look the same? And that's going to be what happens. The best way I can explain this is like this, is, okay, if you're, you know, traveling along on a road and you see those mountains way out there and you see that they, you know, appear to be nice and round and everything is smooth, right? Everything looks completely smooth and it's wonderful, and then the sun's setting behind you is great, okay? But then as you get closer and closer to those mountains, they don't look so smooth. They got rocks pointing out of them, okay? They look completely different than what you had, which is what this function, this right here, is your up-close function, all right? This is what those mountains look like up close. They got waves, they got curves, they got stuff going on with them. But if I step myself way back, the end behavior, it's nice and smooth. There's not much happening to it, okay? That's what an end behavior model is, okay? In general, polynomials have an end behavior model, okay, of their first coefficient, okay? And that's all that this is saying, is that g of x is my end behavior model for any function that looks like this right here, all right? So here's an example. So I want to find the behavior model for this function right here, for f of x, okay, as a rational function. And so what I'm noticing here, and what I'm going to go through, is based off of what I just told you, okay, my end behavior, my end, not end, end, okay, well, what's happening at the top? My end behavior for the top is going to be 3x squared. Okay, my end behavior for the bottom is 4x squared. That means when I push way, way out, that's what it's going to look like. But what is 3x squared over 4x squared? That's just 3/4. Well, what does that mean? Okay, this means at this point right here, what does this mean? It says 3/4. It's going to look like 3/4. It looks like a line. And that's exactly right. If I were to take this function right here, graph this right here, okay, and graph it, and then zoom way out, even though there'd be some waviness going on, there'd be a hole there, there'd be something way going on, but now if I zoom way out, it's going to look just like a flat line. Mind-blowing, right? Just by zooming out, okay? So in this example, the end behavior is modeled by what we just found, y equals 3/4. If you notice, because of that, it is also a horizontal asymptote with a graph of f. We can use this end behavior model of a rational function to identify any horizontal asymptotes. It's just another way of identifying horizontal asymptotes, okay, besides using the limits that we already did. You can start doing it rational that way. It's another way of saying, you know, hey, Bobo button, right? blah blah, and eats DC. It's just another way of doing it, another title of saying what's an end behavior model. Okay? More formally, okay, what I'm able to say is, well, if I have an end behavior model and I want to talk about the right end behavior model, that means I want to zoom out to the right. I want to look over to the right and zoom way back. So that is why x is going to infinity. If I take f of x, my original function, okay, and I compare it and divide it by my end behavior model, and I zoom way out, or I take x to positive infinity, I should get 1, and that means that I have a good end behavior model. Same thing for the left. Okay, this is the math part of proving a possible end behavior model. Okay, to show that this is an end behavior model that will work. I'll be honest with you, this part right here, okay, we're not going to worry about it a whole lot. All right. What I do want you to concentrate on is what is an end behavior model, not proving it. Does that make sense? This proving part, you're not going to have to worry about so much, but you do need to know what an end behavior model is, which is why I have these here. Okay? So the question becomes, is what I need to take a look at is I need to go, well, what end behavior model works for this? So when I take a look, what I need to be looking at is, well, the end behavior. So again, I want to do the end behavior of this is going to be 2x cubed. That's my highest power. My end behavior for the bottom is going to be x. So when I do my simplification, I get 2x squared. Now I have to ask myself, which one of these functions, which one of these graphs looks like 2x squared? And I'm going to say this one goes with A. Alright, I'm going to go ahead and pause the video. I'm going to ask you to do 36 through 38 on your own. See how you did. Alright, put your answers in there. Alright, and we'll hopefully match up. Here we go. Finally, here you go. These are your answers. Hope they match up. Should have gotten CDB. Again, if you have any questions, feel free to holler back at me. Finally, here's your last assignment for part 3. Okay, remember, all homework for section 2.2 is due in 2 more days, and we'll also have our quiz. All right. If you have any, I look forward to seeing you tomorrow. Hopefully this went well. Talk to you guys later. Bye.